This is Mrs. Phipps. I made a bit of an oops. I managed to turn my recording off the last time. So I'm going to just kind of jump back in on that second part with the yo-yo example. So this is the yo-yo example of centripetal force. I'll try and put those two things together before I post it. Okay. So for the yo-yo example, basically you've got a yo-yo and you're spinning it vertically in a circle. Top, basically going up and it's coming down. So you got this yo-yo and the yo-yo is going in a circle, and so you got two places. Here's the top. We're going to start there. And so at the top, the yo-yo is attached to a string, and that string is, the string is attached, basically going around the center of axis. So the question is, what's happening at the top? What are our forces that are acting there? So if it's at the top, well, it's on Earth, so it's got the weight force that's pulling it down. And it also, it's attached to the string. The question is, which way is that string? Which way is that tension going? Is it going to be going this way, up, or is it going to be going down? It has to be going down. If you remember from way back when, a tension has to be a pull. It can only be a pull. It cannot be a push. So the tension is basically pulling it back into the center. It cannot be up at the top. So we've got the tension and it's pulling in. So we're going to go ahead and so there's step one, free body diagram. Step two, you're going to set up Newton's second law. Now in this case, so the net force is equal to mass times acceleration. But in this case, the direction that we're dealing with is not x, it's not y, it is the centripetal. That's the force that is the net force that is keeping it moving in a circle. All right, now before we go any further, we need to address this. What way is this going? Is the weight and the tension really pointing down? Okay. Well, let's look at conventions that we have so far. All right, and the thing is, they're just conventions. We choose them and we accept them. So generally saying, if something is moving in the x direction, we call to the right positive. If it's moving vertically, we call up positive. So what do we call positive if something is moving in a circle? If it's moving in a circle, toward the center is positive. All right, so for centripetal motion, positive is always toward the center. That's basically how you determine your direction. So in that case, when we put this together, okay, our weight and our tension are going the same way, so we're going to be adding them because they're both going to the center. They're both positive. So weight plus tension will be equal to mass times the centripetal acceleration. So when we ask you what's the centripetal force, the centripetal force is a combination of the weight and the tension. So if we're going to solve for what is the tension in this case, tension will be equal to mass times acceleration minus the weight. Okay. And what's our this? So it's mass times velocity squared over r minus mg. Okay. All right. So let's try it from another point of view. Let's see what happens to this tension if we say we're dealing with something at the bottom. So here's at the bottom. It's still going to pull in. All right. It's still going to connect to this center of motion. But now when we draw a free body diagram, it looks a little bit different. So what are our forces? Well, the tension force is still pulling it, except now the pull is up. And we also have the force of gravity, the weight force, because the weight force always pulls down. So that's why there's a little bit of a distinction here. So our net force, in this case, it's the centripetal force, it's the force keeping it moving in a circle, is going to be equal to mass times the centripetal acceleration. Okay, so what happens here? We now have tension is our positive because it's going towards the center, minus the weight, okay, is going to be equal to the centripetal acceleration. So our tension is now mass times centripetal acceleration plus the weight. All right, so tension is mass times velocity squared over r plus mass times gravity. And yes, you can factor out that if you factor that out if you want. So if we're going to call this was our bottom, right? Bottom, and this was our top. So what we can deduce from this is that the tension at the bottom will always be greater than the tension at the top, because the tension at the bottom adds the weight force, whereas the tension at the top subtracts the weight force. Okay, and that was the last bit I needed to share you. I wanted to share with you how centripetal force works, that it's not its own type of force, that it's really the sum of the forces that is keeping something moving in a circle. All right, good luck on the work. Talk to you later.